Hello, good afternoon. I'm Joseph Chen from Hong Kong U Business School. I'm your moderator for these sections. These sections will be an online one with Dr. 𝗧𝗺𝗺 to share with us the technology knowledge and insight about 3D printing in space. Dr. George 𝗧𝗺𝗺 is CEO of 3DK Tech, a pioneering metal 3D printing startup. In 2012, Alex started his Hong Kong journey in the Department of Mechanical and Aerospace Engineering at Hong Kong University of Science and Technology. His research focus is on metal 3D printing for industrial applications. His team has successfully developed a groundbreaking technology that significantly enhances the efficiency and reliability of existing metal 3D printing processes in the market. Motivated by their breakthrough, Alex and his friend 𝗢𝗚𝗫 co-founded 3DK Tech in 2017, focusing on the application of their patented USLM metal technology for 3D printing, and they were awarded a gold medal from the World Intellectual Property Organization. It is our honor to have Alex joining us. Without further ado, please join me to welcome Dr. 𝗧𝗺𝗺𝗺.
Hi, everyone. I'm Alex, and today, I'm going to talk about 3D printing in space. Now, let me tell you why I'm talking about it. Partly because I've spent the last decade working in 3D printing, getting a PhD in mechanical and aerospace engineering. I've invented a new metal 3D printing technology that is specifically tailored to solve some of the issues that we have in space and at home. I've founded a 3D printing company, and I myself am a lifelong Trekkie and astrophysics and space nerd. So let's start from the beginning. What is 3D printing? Well, 3D printing, we live in a 3D world, but to build a 3D object, we have to start from like a simpler model. So we take a 3D object and we slice it in 2D elements. And then we take the 2D elements and then we slice them in single dimensional elements. And then we take those and then, and then we just start depositing them on a particular platform or substrate, as we call it. This is how you take a 3D object and assemble it like one step at a time. There's many ways of 3D printing. The way that we like to do it, and especially for metal, we do what is called powder bed. This basically means that you lay a metal powder on top of a substrate or a platform, and you use a heat source that either sinters or melts the material that you're looking at. So the heat source can be a laser, an electron beam, which sounds very exotic, or other ways. But basically, you take that powder that you laid it, you add a heat source to it, and that allows you to take the material from regular temperature to liquid temperature, and then you go back down. The powder bed technique specifically provides a high dimensional accuracy, and that allows you to do, you can make more smaller features possible, like you're more precise with the printing that you can do. The downside of it is that you have lower productivity. So you print slower, and because of that, and partly you also need support structures. So other things that you need to print so that it supports the larger part that you're making. You can see in the pictures right now, basically how, like a representation of how that's done. There's another way of doing it. It's called an extrusion method. And you've met this with your, if you've ever seen plastic 3D printers, those are FDM, fusion deposition modeling. That's what that's called. The extrusion methods, you can change the material and you can change the process, but like the whole thing of it is still extrusion. You have a material, whether it's plastic, ceramic, or metal, and you feed it through an nozzle, and you need an energy source. Again, this has a few particularities and a few benefits. One of which is it's good for repair. So if you have a part that broke down, you can take away the part that is broken and then add the material. You can see that in the picture right here. You can just simply add the part, add the new material on top of it to replace the broken part. You can build larger parts. You can put this on a robot arm and actually like print larger things. And it does have a high productivity, which means that you can print faster. The downside is that it has a lower accuracy. That means that, well, lower accuracy, lower tolerance, and more post-processing. Let me break that down. So basically, low accuracy, low tolerance just basically means that when you're building, your 1D slice that we talked about earlier is a little bit larger. So the parts that you can build, the accuracy of them is lower, and also the features that you can build with them are, again, kind of large, so you don't have that like preciseness of it. And also it does require some extra thermal. You got to put it in a furnace and do a bunch of other things. Now, let's talk about the importance, and if you do 3D printing right, what it can do. So right now we're looking at, why metal 3D printing is important to our life, and how it can impact us and how it can impact industry. We're looking right now at a compressor blade assembly. Now, this is basically a 17-piece assembly, 16 blades, one rotor, 16. It's a compressor assembly. So basically, it takes the air in a jet engine and compresses it so that it can then go into a combustion assembly. This is one simple part, well, not simple, but this is one part of a turbojet engine. Now, if you manufacture it currently, it will take between 3,000 and 5,000 hours to manufacture, to make conventional. And well, 2,000 and 5,000, sorry. And it will cost between 30,000 and 80,000 US dollars to manufacture. If you 3D print this, it could potentially go down. My technology, our startup's technology can potentially reduce that by a factor of 10, while maintaining the durability and the functionality of the part that is 3D printed. That means that we can make the parts with 3D printing. Using 3D printing, we can make them faster, and we can make them cheaper. Can you pause? Yeah. So, like I mentioned, metal 3D printing can really help manufacturing a long way by reducing the cost and manufacturing time of very valuable components. Now, obviously, 3D printing has a lot of proving to do. And because of that, we've been working with HAECO, which is the Hong Kong Aircraft Maintenance and Repair Operations, 𝗖𝗍𝗄, a semiconductor company, and mobility companies, and a few others. Actually, we're also working with utility companies. And the whole point is the end goal is to 3D print critical functional components. That's basically your compressor blade assembly, the one that I just showed you. That has the highest value that can be had. But to get to that, because it's a high safety, because the safety is very important, we have to prove it along the way. So to do that, we go through a roadmap to make sure everything along the way follows the standards and all the testing and certification that is needed. And because of that, we're starting out with tools, functional components, next non-critical functional components, and then critical functional components. And this actually happens with all the industries in which we're trying to work. Right now, metal 3D printing has been mostly used for prototyping, and it's created a bottleneck. And this is where we believe metal 3D printing is going to, and that is critical functional components and user components. So it can have a real impact on what we do with the manufacturing technology that we develop. Now, let's talk about what that what that impact can have on our adventures in space and how 3D printing in space can happen, right? There's a few ways. So there's a few things that you can 3D print in space. You can, well, outside of Earth, let's just say. You have printing habitats, you can 3D print organs, or you can 3D print tools. And we'll go at it step by step. Let's talk about habitats first, because that's something that NASA is specifically investing in a lot right now. And it's supporting startups that are actually developing in that regard. So NASA is supporting a few companies like AI Space Factory, Icon, 𝗬𝗏. The point of the support and these investments is to help basically set up bases either on the moon or on Mars, and those will help us set up. Those will reduce the cost of us actually setting up a base either on the moon or on Mars by using lunar regolith or Martian material to set up habitats for the first people that are going to live there. That reduces our cost by allowing us to just ship not the building material itself, but the equipment that is going to build the habitats using using what we call in academia, we call that in situ, which is basically means we use the resources that are available where we go to build what we need to build to perform the task that we need to perform there. And in this case is habitats for humans on either Mars or the moon, using some of these technologies that are building that are being tested right now on Earth. So that's very exciting. More down to earth, though. Now, there's a few things that can never be 3D printed on Earth. One of which is organs. Now, organs, like, I don't know how much you know about organs, but there's been a lot of there's a lot of people out there that require organ transplants, and there's only so much people that are donors, and you don't really want donors to die, right? So you don't want them to die, and you don't want the people that need organs to die as well. So you need to find a way to create organs that are going to be accepted by the body and that you can manufacture. That's been a major driving force in the medical industry. Unfortunately, you can't really 3D print that on Earth, partly because of the gravity. Well, 100% because of the gravity, because we can do it. You just take stem cells, scaffolding, and you can 3D print that in a particular medium environment. But because your organs, when your organs are formed, it actually they grow slowly over a long period of time. And because they grow over a long period of time, gravity itself doesn't have a large effect on them. But if you're trying to 3D print them faster, gravity will actually have an issue, will create issues on the organs. So you need to create scaffolding and other things that are not going to really generate the right amount of the right structure of the organ. So if we can 3D print organs in space without gravity, that will allow us to build organs that are of the right shape and of the right composition. So there's already been a few a few attempts. For example, in 2019, NASA biofabrication facility, they 3D printed cardiac-like tissue. And in 2022, there was also, obviously, at the on the ISS, there was a human knee meniscus 3D printed in orbit. The fact that it doesn't have gravity is specifically what makes it possible. So, further testing and experimenting on that will really allow us to start 3D printing more complex biological material. So that is, honestly, that's an exciting, that's very exciting for me, because think about it. You won't need to worry about, a particular organ of yours fails, and there's no one on the donating list that is either a match or like you're down the list. This way we can 3D print using your own stem cells, so there's no risk for non-compatibility, non-biocompatibility, and you can just grow it, 3D print it in space, and then send it down and implant it and replace the organ that is failing in you. That honestly, that feels very sci-fi. And going from like the bigger, the better, and now we're just like the more pragmatic. We're in printing tools. So this is something that we've actually already done. ISS has been doing this for a bit now, for a few years. Made in Space is a company that has been 3D printing different parts in space. They started off with plastic, and recently they've just started printing metal. benefit of doing this is that, well, let's say something happens in space and you don't really have the ability to let's say you didn't think to bring that particular tool, or if you have to think to bring all the tools, it's just going to take a lot of weight and a lot of space, which is very valuable when you're sending things to space. So the benefit of 3D printing your objects in space is that, well, one, you can just take the raw material. Raw material can be, let's say, powder, and that just takes the volume that you have, whether it's a cube or whatever it is. And then you can just 3D print the part that you need. So they've been doing plastics, and they've been using those tools to actually repair some of the parts in space. And so basically, this is very useful for in space and in any sort of situation where you don't have all of the knowledge, there's a lot of things that can happen. And having the flexibility to build a tool that is very specific to the need that you have at the moment, without you needing to predict it at the beginning, is going to be very useful for astronauts, helping them, address the issues that come up without the team on the ground having to predict everything and having to pack everything without like knowledge, right? This is basically when you go from, we've done this before, so we know what to expect, versus we haven't done this before, we don't know what to expect, but we've incorporated some tools such as a 3D printer that allows us to react in a moment and figure out the solutions to the problems that we cannot predict what those might be. So this is, again, a very useful tool for our first step into space. And obviously 3D printing has a long way to go, and it can have a long impact in space. And we talked previously about biologics, different environments, different like I mentioned, different gravity wells like the moon or Mars. So the challenges to 3D printing in space are specifically that we've learned to 3D print things on Earth. Some companies have learned how to 3D print in space as well, but some of the challenges are, depending on the technology, microgravity, which is scientific term for zero gravity, can pose some issues in different technologies. The powder bed metal 3D printing technology that we mentioned earlier at the beginning of this presentation, that is, you can't do that in microgravity. You can't do that without gravity. You need something to pull down the powder. So there's different techniques that you have to apply. And at the same time, each gravity well, and by that I mean, whether you're on Jupiter or Mars or Titan or Earth, you're going to need to account for that gravity, right? So that's another challenge. That's another learning experience. There's also limited experience with doing this. We have limited experience with this on Earth as well, but you can imagine in space, it's so hard to do new experiments. So we have to keep trying new things. Now, how can metal 3D printing in space help us on Earth? And I love this this topic because, well, let's look at the math, right? The There's a lot of global CO2 emitted specifically by manufacturing, by making things. And about 30% of that is, emitted by the manufacturing sector. That's around 10 gigatons, right? 10 gigatons a year are emitted by the manufacturing sector, or like all aspects of manufacturing. If we can do that in a different setting or better, we can really help our planet heal faster. And so looking at all the manufacturing that happens on the Earth, we can look at, well, what can we make in space rather than on Earth? I did mention earlier that there's 3D printers in space right now on the ISS. They're made by a company called Made in Space. And I mentioned before, these are companies that these printers can make plastic or ceramic tools for the ISS crew to fix or help address some issues. But the way that I see things is, as we grow as a society and as we grow in technology, we'll be able to eventually 3D print our space, our satellites, all our things in space. So instead of, having a CubeSat that is made on Earth and then launched into space, you can potentially 3D print that in space directly. And that would be like a first step. And then the next step would be, well, you were talking earlier about the ISS, and NASA right now has plans on building and launching, I forgot exactly the term, but basically a satellite that is going to orbit the moon so that we can have transfers between Earth and moon, and landing on moon and then launching again. And that will help also launch into to the Mars orbit. What if we have the ability to 3D print our satellites, our waypoints? Just, they're going to be in space, why not build them in space? And that's something that 3D printing can really open up. And if you look further into the future, I don't know if you guys are I don't know, science fiction nerds, but I am. And I always view things as, how would Star Trek do it? How would you do it in a Star Trek world? And that's like, you'd 3D print or you'd make it in space directly. And that's one of the picture that you see right here. And now the way to do that, obviously we have ideas on how to make that happen, right? And our suggestion is to start mining. Obviously mine asteroid ore and separate the metals that you mine out of M-type asteroids. Yeah, M-type asteroids. Separate the metals, melting them using either solar or nuclear fission. Then you can separate them because there's going to be a lot of different materials that are a lot of different metals that are going to compose the asteroids. And you can separate those, the precious ones and the not so precious ones, like the iron, the carbon, the titanium, the vanadium, etc. The benefit of 3D printing in space and separating those alloys, those materials in space, is that you don't have the environment that is going to suck away the energy. So you can have near 90% thermal efficiency using 3D-Ks, my company's software and hardware that allows us to to 3D print assemblies and parts at a much higher quality and durability. We can see how we can go from mining the asteroids that we have, and extracting the iron and carbon and vanadium and whatever alloying materials we need to create the right material for the particular task. We can start building and constructing spacecraft that are specifically made for the environment in which they're going to inhabit, such as space. To give you an example, or to give you a differentiation, why do you think all of science fiction's spacecraft is so different from the spacecraft that we have right now? So everything we have right now, rockets, SpaceX, and what they're doing is very cool. Like the way that it looks is very cool. But everything that we have to launch from our Earth is completely different. It is very cylindrical. But that's partly because, well, that's entirely because it has to fulfill certain roles. And that important role is getting to space, low aerodynamic coefficient. But in space, there's no air, so you don't need to worry about drag. You don't need to worry about aerodynamics in space. So that's why you can potentially 3D print components that don't care about aerodynamics. And at the end of the day, it could be potentially like a passive income stream. You can, manufacture a 3D printer, launch it into space, make it mine an M-class asteroid, you can separate the metals, you can send the precious metals to Earth, so like the golds, the platinums, the silvers. You can launch them to Earth. You can use the iron, the carbon, the chromium, all the other very useful metals, and you can 3D print locally next to the meteor. Then you can use those to print engines, print small ships for delivering all of the precious metals back to Earth. And like profit. So that's basically why I believe metal 3D printing in space is going to be a very important element of our future. And I'm very bullish on it. And I've spent the last 10 years working to develop part of it. Now, thank you so much for your time. Please let me know. Please ask me any questions. I'm happy to answer anything you might have.
Thank you, Alex. So it is a very short time period, but we have learned a lot from you. We look forward next time that we are going to meet you face to face, and then we are going to hear more insights from you. Again, thank you very much, Dr. 𝗖𝗓𝗪𝗍𝗔. Thank you.